In the past, Egyptians often used a number system to solve mathematical problems involving counting, multiplication, and fractions, and they wrote them on a piece of paper called papyrus. They used to write numbers from right to left. The unimportant part was written first. Ancient Egyptian texts could be written in hieroglyphics and hieratic. In both representations, the number system is always given in base 10. The Egyptian number system should have been added. Large numbers were represented by collections of reliefs, and the value was obtained by adding the individual numbers together. Babylonian mathematics refers to all the mathematics of the peoples of Mesopotamia, modern Iraq, from the early Sumerians to the Hellenistic period, almost until the dawn of Christianity. Babylonian mathematics was written using the sexagesimal number system. The sexagesimal system was probably chosen because 60 is evenly divisible by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. Also, unlike the Egyptians, Greeks, and Romans, the Babylonians had a true place value system in which the numbers in the left column represented larger values, as in the decimal system. Greek mathematics refers to the ideas that emerged with mathematical texts written on the shores of the eastern Mediterranean from the 7th century BC to the 4th century AD, from the Archaic period to the Hellenistic and Roman periods. Greek mathematics is thought to have begun with Thales and Pythagoras. Greek mathematicians lived in cities spread across the entire eastern Mediterranean, from Italy to North Africa, but were united in terms of culture and language. Greek mathematics was much more complex than the mathematics developed by earlier cultures. All extant records of pre-Greek mathematics show the use of inductive reasoning, that is, repeated observations used to establish rules of practice. Greek mathematicians, by contrast, used deductive reasoning. The Greeks used logic to conclude from definitions and axioms and used mathematical certainty to prove them. The Indo-Arabic numeral system and the rules for the use of its operations, which are used around the world today, developed in India during the first millennium AD and were transferred to the Western world through Islamic mathematics through the work of Muhammad ibn Musa al-Khwarizmi. Islamic mathematics also developed and expanded the mathematics known to these civilizations. From ancient times to the Middle Ages, periods of mathematical discovery were often followed by centuries of stagnation. Beginning with Renaissance Italy in the 15th century, new mathematical developments interacting with new scientific discoveries continued at an accelerating pace to the present day. In the classical mathematics period, lots of works have written and calculus was invented. Names such as Euler, Laplace, and Lagrange have brought dozens of theorems to mathematics. With Euler, analysis has become a new branch of mathematics. Engineering branches benefit the most from Laplace's work today. The first important work on probability theory is by Laplace. That is, the derivative has ceased to be the inverse of the integral. Later, Riemann, Weierstrass. Names like Cauchy formed the theory of complex functions. Again in this period, theorems such as group ring ideals theory, matrix algebra, and vector spaces were discovered and developed. This period has an important place in changing the perspective of mathematics. While mathematics was used for calculations in the previous periods, with this period it started to come to the forefront with concepts rather than calculations. Thus, a new era has begun. The period of modern mathematics covers the period from the 19th century to the present day. The main features of mathematics: it is more abstract than in any century, in the conceptual structure,